Good morning, all of you. This is Shahida Khan from Department of Information Technology, Acropolis Institute of Technology and Research. I am going to discuss the basic concept of a stack. After completion of this topic, a student will able to get the knowledge of complete knowledge of a stack. At the same time, a student will able to make some small application on the stack. Topic which I will cover are introduction, array representation of a stack, linked representation of a stack, multiple stack notations that is infix, prefix, postfix, operation on the stack that is push, pop, create, get, top, empty, and the application of the stack. Now, what is stack? A stack is basically a linear data structure which follow the LIFO property. It means the element which is inserted first in the stack will be deleted last from the stack. In stack, insertion and deletion both perform only at the one end, that is called the top of the stack, and stack is basically a recursive data structure having pointer to its top element. Now, the next one is the operation on the stack. The first operation we perform in the stack is push operation. Push means adding an element on the stack. Leftmost figure left shows the stack in which two elements are there, 23 and 93. 93 element is the second element of the stack, which we call as a top of the stack. If we want to add 10 element in this leftmost stack, then we will insert this element from the top of the stack, as we told that these insertion and deletion both can perform from the only one end of the stack, that is the top of the stack. So 10 is inserted at the topmost position of the stack as figure depicts. Now, next operation on this stack is pop operation. In this, removing an element from the stack is called the pop operation. Here, the leftmost figure shows the stack containing three elements. Top is the 12 is the topmost element of the stack. If we want to perform pop operation, then the lastmost element, that is 12, is deleted from this stack, and after deleting this 12 element, this stack become rightmost stack, in which only two elements are there, 23 and 93. Now, next, how this stack grows. In the push operation, as you can see in the figure, if top is equals to -1, it means the stack is empty. No elements are there in this stack. And if top is equals to, if we want to add an element in the stack, firstly we have to increment the value of the top by 1. Then after we will insert some element in this stack. That is, if we want to insert A in the leftmost stack of. So firstly we will increment the top element by 1. Now the top become 0 from -1 and insert A. And after that we have to insert B. So again we will increment the top by 1 from 0 to 1. Top is incremented from 0 to 1 and we will insert B element, and so on. Same procedure perform in the pop if the stack contain A, B, C likewise. So if we want to pop some element in this stack, so firstly the topmost element is deleted. So C is removed from this leftmost stack and elements become A and B. And after that, if we want to pop again the next element, so B is removed, and so on. Now, next is array implementation of a stack. In array implementation, a stack is formed by using array. All the operation regarding the stack are performed using array. Adding an element onto the stack is called push operation. So, if we want to add some element on this stack, so firstly we have to increment the value of top so that it can now refer to the next memory location, and after incrementing the value of top, we will insert some element at that particular position. Now, as I showed you earlier, the push operations perform likewise, and the next one is the algorithm of push operation as well as the function of push operation. Suppose if we want to add some element in this stack which is already full, so how can we insert the element in this stack? So firstly we will check that whether the stack is full or not. If top is equals to n is the size of the stack. If top is equals to n, it means this stack is full, so we will not be able to insert some element in this stack. So the condition arises, which is called the overflow condition, as the first function, first two line shows. And if this condition become false, if top is not equal to n, it means that the stack is not full. So we can insert some elements. So firstly we will increment the value of top by 1, then after we will insert some element at that particular position. So this is all about the array implementation of stack. Now algorithm and function for pop operation. As we can say that in push operation condition arises which is called overflow. In case of pop operation, condition arises which is called underflow, in which if we want to delete some element from the stack, and if stack is already empty, so how can we delete an element from the stack? So firstly we will check whether the stack is empty or not. So the condition top is equals to -1, it shows that the stack is empty. If condition is true, then underflow condition arises, so we can't do anything, we can't delete an element from an empty stack. And if this condition become false, it means that the stack contains some element, so we will delete some element from this stack. So for this we will decrement the value of top by 1. Now the next operation performed on this stack is peek operation. Peek operation return the topmost value from the stack, as well as pop operation delete the topmost value from the stack. That is the basic difference between the pop and the peek. Here the peek function shows that if top is equals to -1, it means that the stack is empty. So we can't delete any element, or we can't retrieve the value of this element. Else, if this condition become false, we can retrieve this element, topmost element, that is called the stack top. So this is all about the peek operation. Now the linked list implementation of this stack. Instead of using array, linked list representation can be performed. Linked list allocate memory dynamically. However, the complexity of both the linked list as well as the array is same. In the linked list implementation of a stack, nodes are maintained non-contiguously in the memory. While in case of array, nodes are arranged contiguously in the memory. This is the basic difference between the linked list representation as well as the array representation. Now the next one is the multiple stack. A single stack is sometimes not sufficient to store large amount of data. So for this we will use multiple stack, in which array is divided for multiple stacks. Suppose there is an array stack n divided into two stacks, stack A and stack B, where n is equals to 10. Figure shows it. Stack A expand from left to right from the 0th element, and stack B expand from right to left from the 10th element. The combined size of both the stack never exceed 10, because 10 is basically the size of the stack. So we can't exceed 10. Now next one is the application of a stack. A stack can be used for expression evaluation, as well as stack can be used to check parenthesis matching in an expression. Parenthesis matching, you can see that if you did programming in C, C++, Java, if you want to do some coding, so compiler also check parenthesis, syntactic error and all other error by use of stack. Stack can be used for conversion from one form of expression to another, that is infix to postfix, or prefix to postfix, or postfix to infix. And stack can be used for memory management. Stack is also used in backtracking problem. Now the expression. The way to write an arithmetic expression is known as a notation. An arithmetic expression can be written in 3 different notation without changing the essence of the output of an expression. Notations are infix notation, prefix, and postfix notation. Now the infix notation. Here I will explain with the help of example. Suppose there is an example A minus B plus C, in which all the operator come in between the operands. It is easy to use. You can see this from this example. All the operators like minus, plus come in between the operands. Now in the prefix notation, all the operators are come before the operands. For example, plus AB. This is equivalent to the infix notation A plus B. In this, the operator come before the operands. This is called prefix notation. Now in postfix notation, it is also called the reverse Polish notation or postfix notation. In this, operator come after the operands. So firstly, operator plus comes after AB. This is equivalent to infix notation A plus B. Now this is the example of various notation: infix, prefix and postfix. Same A plus B can be written in prefix operation like plus AB, in postfix operation notation like AB plus. In the second example, if A plus B is written in bracket, firstly you have to perform this. In case of prefix, plus come before AB and then plus AB and into C. After performing this operation in prefix notation, we get the into plus ABC. Similarly, in the postfix operation, postfix notation, we get AB plus C into. Same perform likewise. Thank you guys. Thanks for patience listening. Have a nice day.